Hello everyone, it's Mr. Rops.
And Mrs. Flynn.
And we're here to talk about the derivatives of e to the x, Euler's famous number. Okay, so let's just find out what e to the x is.
Let's just think about what the function is. Like, we'll just write it over here.
Okay.
If f of x is e to the x. What does that look like on a graph?
Right.
Oh, here it is.
Right, I took a liberty to just click on the graph. There we go. And so if we look at it, I think that's e to the x. It should be. So so there's e to the x graphed for us. Let's go to the derivative now and turn the derivative on, and let's graph it.
Working.
Hold on. What happened? Where's the derivative?
Something crazy's going on.
Let's go back. Okay, let's make the derivative bold for a moment. Let's see if we can see where it goes. Okay, graph. Oh, it's right on top of it.
Fancy, fancy.
Fancy, imagine that. So the derivative of e to the x is simply e to the x. It is itself.
This is in your IB packet.
Okay, so let's do an example then.
Okay, let's calculate the derivative. dy dx.
And so here, it's a chain rule scenario again. So I have an inside function, outside function. The inside function's the 2x, and the outside function is e to the power x. So I take the derivative of e to the 2x, that's just e to the 2x.
But now we have to take the derivative of the function.
Right, the inside part, derivative of 2x is 2.
So I clean that up. It's 2 e to the 2x.
Nice, done.
Next one.
All right, so
all sorts of stuff going on here.
Right, dy dx. So we have, again, we have a chain rule scenario.
Okay, so let's take first the derivative of the whole.
Right.
So, or the outside
function.
Right,
outside function. So the 3
times e to the negative x plus e to the x. Bring that down by 1. And then we take the derivative of the inside function. So that's right here.
So then just going to be e to the negative x times negative x derivative, which is negative 1, plus e to the x. I have to make sure we put parentheses around this whole thing here, because it's the whole function theirs are multiplied together.
All right. So do you want to clean this up? You're going to tell me no, aren't you?
Let's clean this one up.
Okay.
Or if we can, well, no, because if we clean it, it doesn't
maybe
really
just right here. That's
okay. Let's clean that up. Okay.
I mean, it's not too big of a deal to just rewrite that as negative e to the negative x plus e to the x.
Okay, let's just leave it like that for today. Because we're just looking at how to take the derivative.
All right, next one.
Next one. Ooh.
Y equals e to the x all over natural log of x.
It looks like we have a quotient there, so we have to use the quotient rule.
Look at old quotient rule. That's u over v equals
v squared.
V squared.
V.
U prime minus u v prime.
Okay, so let's just dy dx.
All right, so let's just square that v.
Yep. All squared. Now it's important to put that in parentheses, because if you don't, then it's just the x that's squared.
Yeah.
All right. Let me write down our bottom again.
V. Now times u prime. U is here.
Right. That's just e to the x.
Minus u, which again,
e to the x.
Times v prime. Here's v.
Right.
That's just 1 over x.
We just learned that one.
I'm going to clean it up a little bit.
Okay.
And can I factor out my e to the x in the top? Is that okay?
Sure.
So now I'm left with just natural log of x minus 1 over x all over natural log of x squared.
Okay, great.
Fair enough.
Okay, next one.
These aren't so bad.
No. Okay, so now we have e to the negative x times sine x.
That looks like a product rule to me.
It does to me too.
And some other stuff in there.
Be a chain rule with that e to the negative 4x. All right.
All right. So should I write it out?
Sure.
Okay. U times v Do you do UV prime?
I never know what I do.
B.
I just know I...
Yeah, it doesn't really matter, right? Because it's just adding.
Right.
Okay.
So dy dx equals our first function to negative 4x
times the derivative of the second
cosine.
Plus the second.
All right. Our sine.
Times the derivative of the first.
Which is going to be e to the negative 4x.
And using the chain rule, multiply that by a negative 4.
Great.
All right, so I have e to the negative 4x cosine x plus, let's go and just make that minus 4 e to the negative 4x sine x. Do you want to factor out?
Nah, let's just leave it like that.
Okay.
Okay, great. One more to go. Let's see what we have in store. Find the slope of the tangent line to the function e to the x ln x at x equal to 1.
Oh, here's our hint. Slope of the tangent line. How do we find the slope of the tangent line?
I know. It is the derivative at the point x equal to 1.
So let's just find the derivative of f of x.
Okay.
Do you want to find the point first?
No, that's fine. That's fine.
Okay.
And we just want the slope. So let's go do our product rule, because we've got e to the x ln x.
All right, so, okay, I'll write it out. uv prime plus vu prime.
All right, so we just get e to the x
times 1 over x plus
v is ln x times derivative of e to the x is e to the x.
All right.
And so then we just have to find it at 1. We plug in...
So I have e to the 1
Yep.
times 1 over 1 plus natural log of 1 times e to the 1.
All right, and that is f prime at 1. And so we get e, all right, we get e, logarithm of 1, that's 0. So plus 0 times e to the 1, which ends up just being e.
So that's the slope of the tangent line at x equals 1.
It's e, 2.7 blah, 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 blah. All right, sounds good.
All right.